Hello students, welcome to Fun Scholar. So today we are going to discuss about the topic perimeter and area, and this topic is made for CBSE class 7 students, but this chapter will be beneficial for all the classes and regardless of the boards. Okay, so let's start. So perimeter and area. Okay, so from the beginning or like from class 4 we have tried to study that what is perimeter and what is area. The perimeter in short is the boundary in total. Okay, so this is the definition, or just in some few words people used to describe it. Okay, so if I talk about this image, the boundary, the total boundary of this figure will be the perimeter, obviously. Okay, and talking about area, the area is the total inside. Someone may say that total inside area, but we are discussing about area. So it would be better that if you call it the total inside part. Okay, that means in this figure this total orange part is the area, and the total red part or total boundary will be the perimeter. Okay, so let's go further. Okay, hello scholars, in this chapter we will able to learn about area and perimeter of different plane figures. Okay, so these are the topics that which we are going to be learned. Okay, let's go next. Introduction to area and perimeter. I want to fence the boundary. Okay, fence the boundary of a field. Can you tell me what is the length of the wire required? Okay, so you need to remember this. There are some terms which we have to remember, like fencing. So fencing requires always the perimeter. Fencing or building a wall, everything requires perimeter. The length of the boundary is called perimeter, yes, which we were discussing sometimes earlier. Okay, so if all of them are 1 meter each and this curved corner area is 1 meter each and all the sides are 10 meter, 8 meter, 10 meter and 8 meter. So total perimeter will be 10 plus 1 plus 8 plus 10 plus 1 plus 8, and 38 will be the total perimeter here. Okay, so this one was very much easy, but not every time we will add the perimeter area or the given sum of the perimeter. It has also some formulas, okay, which we are going to discuss in upcoming slides. So introduction to area and perimeter. I want to find out the amount of space inside the region. Okay, so remember the space inside the region. So what should I find? For this you need to find out the area of the given figure. So the area of the square field is side into side. Yes, the formulas I have been talking about, that is the area of a square is side into side. Yes, we have already learned about this in our previous classes. So let's go further. Okay, in lower classes we have already studied how to find out the area and the perimeter of different shapes like rectangle, square or many other regular or irregular shapes. Okay, so let's recall. So here is the formulas of everything. The area of a rectangle is length into breadth. Perimeter of the rectangle is 2 into length plus breadth. The area of a square is side into side, and perimeter of the square is side into 4. Okay, so this is the image of a rectangle and this is the image of a square. So what is the difference between rectangle and a square? The rectangle has one pair of equal side, opposite equal side, and for the square all the sides are equal. Okay, so let's go further. Okay, a footpath of uniform width 5 meter runs around the inside of a rectangular park 38 meter long and 32 meter wide. Find the area of the path. Okay, so basically in this figure here they are talking about a 5 meter path going all around the rectangular park. Okay, so you have to find the area of the path. Okay, so to find that we have to find first the area of the rectangular path. That will be 38 into 32. Then you have to multiply this. Yes, this is the complete area of the rectangular park. Okay. Now, if you remove the path area, you will get the inside rectangle. So, that will be 38 minus 5 into 32 minus 5. It will be 33 into 27. Okay. So, if you multiply these two, you will get 6 to the 8, 891. Now, if you subtract these two, you will get the area of the path, that is 1216 minus 891. Okay. The area of the path will be 325 feet square. So, this was the general sum of this. Okay. 382116. Okay, so 38 minus 20. Okay, no, sorry, we have done a little mistake here. It will be 38 minus 5 and 32 minus 5 minus 5. So, it will be 28 into 22. Okay. So, this one is the area of the path before connecting the two paths, and this will be the area of the rectangular park without the path. Okay. So, and its answer will be 616 maybe, sorry 600. 600 will be the area of the path. Okay. So, let us go further. Okay, area of a parallelogram. Now, okay, these topics are new inclusion. Okay, we have already studied about rectangle and the square, and these are the parallelogram and trapezium. This will be included in your current syllabus. Okay, now we will see how to find out the area of a parallelogram. And we convert a parallelogram into a rectangle of a equal area. Okay. So, in this method, we have to just consider this parallelogram as an rectangle, and to do that, we will cut this curved area. Okay. So, then it will be turned into a rectangle. Okay. Yes, just like they have did it. Okay. So, area of a parallelogram is the area of a rectangle, that is length into breadth. Okay. The length L and breadth B of the rectangle are exactly the base and the height of H respectively of the parallelogram, and this part will be turned into a right angle triangle. Okay. We will discuss this later in upcoming slides. Any side of a parallelogram can be chosen as a base of the parallelogram. Okay, the perpendicular dropped on that side from the opposite vertex is known as the height or altitude, like this part. This part will be known as the height. Okay, and this is a right angle triangle. So, in the parallelogram ABCD, DE is perpendicular to AB. Here AB is the base and DE is the height of the parallelogram. In this parallelogram ABCD, BF is the perpendicular to opposite side AD. Here AD is the base and BF is the height. Okay. One of the side and the corresponding height of a parallelogram are 4 semi and 3 semi respectively. Find the area of the parallelogram. So, that will be base into height, that AB into DE, and it is a very easy one, 3 4s are 12, 12 centimeter square will be the area of the parallelogram. Okay. Next, the two sides of a parallelogram ABCD are 6 semi and 4 semi. The height corresponding to the base CD is 3 semi. So, we have to find the area of the parallelogram and the height of the corresponding base AD. Okay. So, in this case, you have to find the base, that means this part. Okay. So, area of the parallelogram will be easy to find, that will be 3 6 18 centimeter. And how we got the 3 here? So, we got basically 3 here just by calculating this area. And how we have calculated it? We have calculated it by taking the 4 area and just by the Pythagoras theorem we have subtracted by using this height square plus base square method. Okay. So, and the base is, let us say, x centimeter, and the area is already been found out, that is 18 centimeter square. So, area of the parallelogram will be b into x, and from that find the value of the x, and x we have thought as the height. So, height will be found out. Okay. Okay, so before going to the next slides, let us watch a video, that is how area of a parallelogram we used to find, or what will be our approach to find the area of a parallelogram. Okay. So, let us start by saying the video of area example.
Respectively. If RS is
Okay, so here was the video that in general how this area of a parallelogram sums usually come and how we generally solve them. Okay, so this one was just like the previous example and we will go further. Okay, the height of a parallelogram is 1/3 of its base. If the area is 108 centimeter squares, then find the height and base. So take x as the height and 1/3 of x will be the base. So x into x by 3, it will be x square by 3 and x will be the root over 324. So 18 will be the value of x and from that we will get the base and the height. Okay. Okay, the area of a rhombus is 119 centimeter square and its perimeter is 56 centimeter. Find its altitude. So from the perimeter we will get the value of the all sides, because in rhombus all the sides are equal, and from that we will get the height as like this. Okay, so this will be the height of the rhombus and base into height is 119. So from that we will get the value of the height will be 8.5, this one. Okay. The height of a parallelogram is 3 dm, that means decimeter. If the area is 240 meter square, find the base of the parallelogram. Okay, it's very much easy. Okay, base into height, 1 dm is equals to 10 centimeter decimeter, and after comes centimeter. So 3 dm will be 30 centimeter and base into height equals to 240. So 30 into, sorry, we have to divide 240 by 30 to get the value of the base. Okay. The next, now we will go further and learn about the area of a triangle. That is, let us find a method to get the area of a triangle. Draw a scalene triangle, and for scalene triangles we know that all the sides are not equal. All the sides are different in measurement. Okay. So on a piece of paper, cut out the triangle, place the triangle on another piece of paper and cut out another triangle of the same size. Superpose one triangle on the other so that they match. You may have to rotate one of the two triangles. Okay, so this one just an example or an experiment which you guys can try at your home. So do it in your home. Okay, now place both the congruent triangles such that a pair of corresponding sides is joined as shown. Is the figure thus formed a parallelogram? Obviously, it has formed a parallelogram. And what have we done? We have just placed two scalene triangles as like this to form a parallelogram. Okay, comparing the area of a triangle and parallelogram, we will find that the base and height of the parallelogram is same as the base and height of the triangle. Okay, so area of the triangle is half of the area of the parallelogram. Obviously, to find the area of the one triangle, we will have to just divide it by 2, because this is the area of the parallelogram. Okay. So an interesting fact, that is, we know that area of a triangle in general half into base into height, and all the congruent triangles are equal in area, but the triangles equal in area need not be congruent. Obviously, like for a scalene triangle and for an equilateral triangle, the area can be the same, but not the triangles will be same, obviously. So let us go further. Find BC if the area of a triangle ABC is 36 centimeter square and the height is 80 centimeter. Okay, so to find this we will need BC. Okay, that means half into height into base is the area which is given as 36, and if ABC is a triangle, so BC will be the base. So we have to find out the base, and height is being given 3. So P will be 24. Obviously. Yes, 24 is given. Okay. So they just did it with the same approach, and this type of sum should be done with the same approach. Okay. So in PQR, PR is 8 centimeter, QR is 4 centimeter and PL is 5 centimeter. Find the area of the PQR and find the value of QM. Okay. So it should be done like this. So draw PQR. Okay, for that QR is 4 and PR is 8, that is the hypotenuse, and PL is 5 centimeters. So PL is, they have drawn a perpendicular to the extended of the QR, that is 5. So if this one is 5, and from that point we will have to draw again a perpendicular from Q to PR, and that point will be named as M. So the area of the PQR is half into base into height, that is 10 centimeter square. Again the area of PQR is giving us this. So the area of the PQR will be same as the area of the PQR as per our findings. So from that we will get the value of QM. Okay. So QM equals to, it will be 2.5, because this height and PL and this height will be same. Okay. So it has been done like this. The next, area of a circle. So before going to the area of a circle, let's watch a video. So just watch one video to understand the whole topic.
Let's draw a circle with a center, and let the radius of the circle be r units. The length of the boundary of the circle we will get 30 tiny arcs on top and 30 at the bottom. But our result will still remain the same.
So this was the discussion that how we have got the circumference of the circle as a 2 pi r and the area of the circle as pi r square, and they have just discussed it about giving an example of the pokes. Okay, so we don't need to go deeper into it, just try to remember the formula of these two, that is perimeter of a circle is sometimes known as the circumference of a circle, that is 2 pi r, and the area of the circle will always be the formula as the pi r square, where pi is the value of 22 by 7. Okay, and someone may take this as 3.414 or something, but it will be better that if you take this as 22 by 7. Okay, so let's go further. Okay, so consider the following. A farmer dug a flower bed of radius 7 meter at the center of a field. He needs to purchase fertilizer. If 1 kg of fertilizer is required for 1 square meter area, how much fertilizer should he purchase? In such cases, we need to find the area of the circular region, and to do that, what we do, we use the formula of this pi r square, where pi is 22 by 7 and r square means 7 square, that is the radius. Okay, so and they have discussed the whole process, like draw a circle and shade one half of the circle. Now fold the circle into 8s and cut along the folds. Okay, so arrange the separate piece as shown in figure, which is roughly a parallelogram. The more sectors we have, the nearer we reach an appropriate parallelogram. Okay, just like this. So if we consider two the sectors, then it will form a little bit of parallelogram. Okay, so they have just called this and like an appropriate parallelogram. Okay, as done above, if we divide the circle in 64 sectors and arrange these sectors, it gives nearly a rectangle. Okay, maybe these all are like some troubled examples, you don't need to go deeper into it. We will discuss this later and we will mostly follow the normal approach. Okay, as done above, if we divide the circle in 64 sectors and arrange these sectors, it gives nearly a rectangle. The breadth of this rectangle is the radius of the circle, that is r. Okay, so this is also a general discussion, you don't need to go deeper into that, and these two formulas has already been discussed, that is the area of a circle is pi into r square. Okay, and pi is what? Pi is a mathematical constant that represents the ratio of a circle's circumference to its diameter. Okay, we will discuss about this in our next classes as well, that how pi is coming. Pi is approximately equal to 3.14159. It's an irrational number as well. Okay, so find the area of a circle of radius 30 centimeter, use pi as 3.14. So for that we know that formula of the radius is 2 pi r and it is being given like 30. So from that we will get the value of r, that is 30 by 2 into 3.14, and it will be 30 by, sorry, not 30, it will be 15 by 314 and take 2 zeros. Okay, and calculate this, you will get the value of r, and from that, oh, you don't need that. So 2 pi r equals to 30. So r equals to 15 by pi. Okay. So to find the area of the circle, we need pi r square. From that, we can say that it will be 15 into 15 by pi into pi. So pi will get eliminated and the answer will be 225 by pi. Pi means 3.14 and it will be 225. Now calculate this, we will get the area of the radius, area of the circle. The next one is diameter of a circle, circular garden, that is 9.8. So from that, find its area. So to find that, we need what? 2 pi r is, diameter is being given. So if diameter is this, then radius will be half of the diameter. So it will be 4.9 meter and the area will be pi r square, that means 3.14 into 4.9 into 4.9. Now multiply this, you will get the area. Yes, they have done it like this, all of this, and let's go further. The adjoining figure shows two circles with the same center. The radius of the larger circle is 10 centimeter, that means it will be this 10, and the radius of the smaller circle is 4 centimeter. So it will be 4. Okay, so find the area of the larger circle, the area of the smaller circle, the shaded area between the two circles. Take pi as the 3.14. So it will be, the first one will be 3.14 into 100. So it will be 314, and the next one will be 3.14 into 16. So it will be like this, and the shaded area will be 314 minus of 3.14 into 16, and the final answer will be keeping out from this. Okay. Yes, the first one is 314, the second one will be 50.24, and the final will be 263.73. Okay. So Saima wants to put a lace on the edge of a circular table covered the diameter 1.5 meter. Find the length of the lace required and also find its cost if 1 meter of the lace cost rupees 15. Take pi as the 3.14. Wants to put a lace on the edge of a circular table to cover the diameter 1.5 meter. Find the length of the lace required. Okay. So the diameter is being given 1.5. If the diameter is given that, so we will get the radius, that is 1.5 by 2, and from that we will get the cost of 1. So the diameter will be this, and the cost of 1 meter of the lace is 15 rupees. So the total cost will be 70.65 rupees. Okay. Okay, so find the cost of polishing a circular tabletop of diameter 1.6 meter if the rate of polishing is rupees 15 per meter square. To find that, we need to find the area. So for the area's formula is being given pi r square, and we will get the area as 2.0096 meter and the cost will be multiplied with it, that is 15 into 2.0096 and it will be 30.144 meter. Okay. Shajil took a wire of length 44 centimeter and bent it into a shape of a circle. Okay. Find the radius of that circle, also find its area. If the same wire is bent into shape of a square, what will be the length of each of its sides? Which figure encloses more area, the circle or the square? Okay. So, if this wire of length 44 centimeter is bent into a shape of a circle, so the perimeter, that is 2 pi r for the cases of circle, will be 44. Okay, so from that we will get the r as the as 7. Okay, so now find the area, that is pi r square, that will be that is 154 meter square, sorry, centimeter square. Okay, so the area for the circle is found. Okay, now they are asking us that if we bend that length of the wire as the square, so what will be the area of the square? So for that case also 44 is the perimeter of the side of the square, and for square we know that all sides are equal, that is 11 will be the all the sides, each of the sides. Okay, and the area will be 121 square, as 11 square is 121. Okay, so in the previous, from the previous one we got that circle has covered 154 centimeter square area and this square is enclosing 121 centimeter square area. Okay, so the circle is enclosing more. Okay, so it's being done. The next one, yes, the circle enclose more of the area and they have found all of them like this. Okay, from a circular card sheet of radius 14 centimeter, two circles of radius 3.5 centimeter and a rectangle of length 3 centimeter and the breadth 1 centimeter are removed. Okay, like this one. Okay, so we have to find, so to do that we have to find the radius of the first one, sorry, the area of the first one, that is pi r square minus again pi r square into 2 plus rectangle of that 3 into 1, that will be so the radius of the circular card is 14 centimeter. Okay, so the area of the circular card will be this and the area of the two smaller circle will be 2 pi r square and that will be 77. Okay, so the area of the rectangle will be 3 into 1, that is 3. So the total area remaining will be 616 minus 77 minus 3. Okay, and that will be 536 centimeter square. Okay. Okay, how many times a wheel of radius 28 centimeter must rotate to go 254 meter? Okay, so first 252 meter means this much centimeter, and for one rotation that wheel is going 2 pi r centimeter, and for this case it will be 2 into 22 by 7 into 28, that is 176. Now divide this by this, you will get the value of how many times the wheel have to rotate to go up to the distance of this. Okay. Yes, they have done it. Okay, next, the minute hand of a circular clock is 15 centimeter long. How far does the tip of the minute hand will move in 1 hour? This one as the similar as the for one rotation, it's taking 2 pi r distance. Okay, the tip of the minute hand will move 94.2 centimeter in an hour. Okay. Before going to the next slide, let's just understand the conversion of units. For these cases, for like area and perimeter cases, it will be beneficial. So let's watch the video here.
By now, you must be aware of some basic units of length used in measurements. Can you name them? Yes, they are kilometer, meter, centimeter, and millimeter. Do you also know the relation between these units? Yes, 1 kilometer is equal to 1000 meters. 1 meter is equal to 100 centimeters, and 1 centimeter is equal to 10 millimeters. But do you know that using the units of length, we can also find the relation between the units of area? How, you ask? Let's consider a square playground where the length of each side is 1 kilometer. Now, can you tell me the area of this playground? Yes, it's nothing but the multiplication of the length of its two sides. Let us see what is the unit we get on multiplying the two sides. We get kilometer square as the unit of its area. Now, what if we wish to express the length of this playground in meters? What would be the area of this playground in that case? We know that 1 kilometer is equal to 1000 meters. So, if we replace 1 kilometer by 1000 meters in this formula, we get the area of the playground as 1 million meters square. This means that 1 kilometer square is equal to 1 million meters square. This is known as the basic unit conversion of the kilometer square to meter square. We can try this unit conversion for meter square to centimeter square as well. We know that 1 meter square can be written as 1 meter multiplied by 1 meter. Now, all we need to do is to convert 1 meter into 100 centimeters in this equation, and we get 1 meter square equals 10,000 centimeters square. And what about the conversion of centimeter square to millimeter square? That's correct. 1 centimeter square can be expressed as 1 centimeter into 1 centimeter. So, by replacing 1 centimeter by 10 millimeter, we get 1 centimeter square equals 100 millimeter square. Now that we know the relation between different units of area, let's solve some questions.
Okay, so it will be better that if you go up to this measurement as well. So 1 centimeter square, 1 kilometer square is actually 10 lakh meter square. Okay, and and from centimeter square to millimeter square, 1 centimeter square is actually 100 millimeter square. Okay, so 1 meter square is equals to 10,000 centimeter square and 1 centimeter square is equals to 100 millimeter square. Okay, so this was the conversion unit, and in this video after that they have discussed about so many types of examples, we don't need that. So just for the calculation we have to remember all of this, okay, and this calculation will be beneficial for this kind of sum. Okay, so 4 equal circles are described about 4 corners of a square so that each touches the 2 of the others. Find the area of the part of the square enclosed by the circles if the side of the square is 14 centimeter. Okay. So the area enclosed by the circle is the area of the square minus the area of the 4 circle. So area of the square is has been given like 14 centimeters. So it will be 14 into 14, that is 196 centimeter square. And the diameter of the circle is, if the diameter of the circle will be 14 as well. If we take this, so it will be the diameter of the 2 circle. Okay, so the diameter of the circle will be 3.5, radius of the circle will be 7 by 2, and that means it will be 3.5. Okay, so the area of the 4 circles will be 4 pi r square, and that will be 154 centimeter square. So the area enclosed by the circle will be subtraction from the area of the square minus the area of the 4 circles. Okay. The area of the circle is equal to the area of a rectangle with sides 112 meter and 88 meter respectively. Find the circumference of the circle. So for that, first find the area of the rectangle, that will be 112 into 88, and that will be same as the pi r square, and from that find the value of r and find the 2 pi r. Just like this message, okay, like this process. Okay, the diameter of 2 silver discs are in the ratio 2:3. What will be the ratio of their areas? Okay, so let the diameters be 2x and 3x. So the radius will be 2x by 2, that is x, and 3x by 2, that is 1.5x, or just normal 3x by 2. So the ratios, the area of the ratios will also be the same. So from that cancel out the pi's and find the areas, that will be 4:9. So from that we get to know that ratio of the diameters and the ratio of the areas will be doubled as the ratio from the ratios of the diameter. Okay. Next one, the moon is nearly this much km away from the earth. It takes a round of the earth every month. How much distance does it travel in 1 month? So it will be 2 pi r, and r will be this. So the answer will be r equals to this, and 2 pi r will be, and if this will be 2420000 kms. Okay. So that's it, that's the chapter, and we have also discussed so many sums from this chapter, and I hope you have liked the video. If you have any doubt, then comment it down, and we will see you in the next class. Okay, thank you, bye.